Good morning, students. Chapter 6, Work, Energy, Power. In last lecture, we have discussed about what is work energy theorem for variable force in one dimension. W is equal to delta K. Okay, and then we have solved some questions. Now, in this lecture, we will study about one of the most important topic, that is potential energy. That is potential energy. Yes, kinetic energy. What is kinetic energy? Capacity to do work by virtue of its motion. By virtue of its motion is called kinetic energy, and its equation is K is equal to half mv square. Okay. Now, what is potential energy? What is potential energy? That we will see in this object. Okay. Yes, potential energy. It is again energy. It is again capacity to do work or energy due to its position. Due to its position. Okay. See here. It is capacity to do work. It is capacity to do work by its position. By its position, or capacity to do work or energy possessed by object due to its position, its position or configuration of body, Okay, capacity to do work by its position, simple way, or capacity to do work or energy possessed by object due to its position or configuration of body. It is called potential energy. It is called potential energy. Now see, what is meaning of potential energy? This definition, how to understand this? Okay, yes, there are different forms of potential energy. Gravitational potential energy, elastic potential energy, electrostatic potential energy. Okay, but in all these cases, the concept is same. First of all, we will think about gravitational potential energy. Okay, if I release this chalk, okay, then what happens? This chalk will move in vertically downward direction due to gravitational force, because gravitational force is acting in downward direction. So due to that gravitational force, this chalk is moving in a direction of gravitational force, that is in vertically downward direction. This chalk is moving in vertically downward direction. Yes or no? Yes, in direction of gravitational force. But now, is this chalk will move by itself in vertically upward direction? See, here it is. Hello. This chalk is not moving in vertically upward direction by itself. It is not moving in vertically upward direction by itself. Why? Because gravitational force is acting in downward direction. Gravitational force pulls object in downward direction. So, if I want to bring chalk at some height, obviously I have to do some work against gravitational force. Gravitational force is acting in downward direction. Okay, on this chalk I have to apply some force in upward direction. Okay, so if I apply some external force on this chalk in opposite direction of gravitational force, then it will move in opposite direction. Yes or no? Yes. So obviously, if we want to bring any object in opposite direction of gravitational force, we have to do some work. And yes, that work is change, that work is equal to change in potential energy. Because what is potential energy? Capacity to do work by its position, or capacity to do work or energy possessed by object due to its position of configuration of a body is called potential energy. Is called potential energy. Is called potential energy. Okay, is called potential energy. If force is acting on body, okay, so due to change in position, due to change in position or configuration, okay, if force is acting on body, so due to change in position or configuration, potential energy also changes. Potential energy also changes. Clear about this? Okay, so yes, if force is acting on body, so due to change in position or configuration, potential energy also changes. If initially I have chalk at this position, okay, at this position, it has some position, okay, so yes, due to gravitational field of earth, it has some potential energy at this point. Now if I bring this chalk at this point, now obviously its potential energy changes. Here it has some value of potential energy, here it has some value of potential energy. So if I do some work to bring this chalk from this point to this point, there is some change in potential energy. There is some change in potential energy. Clear about this? So what is definition first of all? Capacity to do work by its position or capacity to do work of or energy possessed by object due to its position or configuration is called potential energy. If force is acting on body, so due to change in position or configuration, potential energy also changes. Okay, now in this topic, in this chapter, we will study about gravitational potential energy. Gravitational potential energy. Gravitational potential energy. Now what is gravitational potential energy? Yes, we have discussed. Okay, if I release this chalk, then this chalk will move in vertically downward direction. Yes or no? Yes. Okay, this chalk will move in vertically downward direction by itself. Okay, if we release or if we drop any object, it will move vertically downward. It will move vertically downward, means towards surface of earth or center of earth. Yes, actually what is center of earth due to gravitational force. Due to gravitational force. Yes, we know that if we drop any object, it will move vertically downward towards center of earth due to gravitational force by itself. Okay, if I drop this chalk, it will move vertically downward direction due to gravitational force by itself. But if I think I want to bring that body from some height to another height, okay, against gravitational force. Yes, but before that we will be clear about what is G. G, that is gravitational acceleration. On surface of earth, value of gravitational acceleration is G is equal to 9.8 meter per second square. But at some height or from surface above some region, we can consider that value of G to be constant. We will consider value of G to be constant, that we will study in chapter number 8. Now see, I am taking one situation. It is surface of earth. surface of Earth. Okay, or we can also say it is reference surface. It is reference surface. Okay, one block is here. One block is here at height y1. At height y1. Okay, in gravitational field of Earth. Okay, and we want to bring this block to this height at height y2. At height y2. What is question? Okay, initially block is at height y1 from surface of Earth, and we want to bring this block from height y1 to y2. Yes, we know that gravitational forces acting in vertically downward direction, but we want to bring this block in vertically upward direction. We want to bring this block in vertically upward direction. And yes, we can think numbers of paths. If I am taking this straight path, if I am taking this path, yes, I will move this block on this path. You can consider any path. You can consider any path. Okay, so see, here it is. Here it is. I am taking this path, for example. I am taking this path, for example. Okay, let we want to move, or we want to bring block from height y1 to y2 against gravitational force. Against gravitational force. Clear about this? We want to break this block from height y1 to y2 against gravitational force. Okay, so yes, this block will not move by itself. We have to do some work. So yes, if we want to bring block from height y1 to y2 against gravitational force, work done. W is equal to work done. W is equal to it is integration. F dot dr. It is F dot dr. Clear about this equation? Yes. W is equal to it is integration F dot dr, or as it is vertical direction. I can write this displacement as dy. Any doubt? Okay. W is equal to F dot dy. Well, what is dy? See, dy is small displacement. In this direction. Yes. We can assume this whole path in very small displacements like this. It is small displacement dy, it is small displacement dy, it is small displacement dy, small displacement dy, small displacement dy, small displacement dy. Clear? Also on this displacement, small displacement, yes or no? So yes, we can think this path as very small displacement. Clear about this? So yes, work done. W is equal to it is integration F dot dy. Clear about this? Now F. Which force is acting on this block? Yes, on this block force acting is gravitational force. That is weight. That is mg in vertically downward direction. Force F here. Force F is equal to mg. It is acting in vertically downward direction. Yes or no? And it is acting in vertically. F is equal to mg is acting in vertically downward direction, and dy displacement is vertically upward. Yes or no? Is in upward direction. So from figure it is clear. Okay, mg means F and dy, they are in opposite direction. Yes or no? Yes, it is. So how to write this equation of work? W is equal to it is integration F dy cos 180. See, F, mg force is acting in downward direction. Yes, it is. Mg force is acting in downward direction. To bring object in upward direction, we have to apply the same force. We have to apply the same force. We have to apply the same force, but in vertically upward direction. Clear about this? Clear about this? Okay? Yes, gravitational force is acting in this direction mg, but we have to apply the same force in upward direction. So W is equal to this F dot dy, it is F dy cos 180. Cos 180 is minus 1. So W is equal to this minus integration F dy. Now integration is with respect to y. Integration is with respect to y. And what is y? Y1 initial height of block from surface of earth. Y2 final height of block from surface. So yes, as we want to bring block from height y1 to y2, then here we have to put limit y1 to y2. Here we have to put limit y1 to y2. Clear about this? So W is equal to minus y1 to y2 f dy. W is equal to minus y1 to y2 f dy. Clear? Now I will put value of f, that is mg. So see how to write. W is equal to mg. I will put value W is equal to mg. See, here it is. Here it is. Okay. W is equal to minus integration y1 to y2 mg dy. Mg and constant, g is also constant, so that it is out of integration. So it is minus mg integration dy y1 to y2. Clear about this? Now what is integration of dy? That you know, that is y. So W is equal to, it is minus mg y. Integration dy means y. Limit is from y1 to y2. So now put limit, upper limit minus lower limit. So here it is minus mg, upper limit y2 minus lower limit y. Clear about this? So yes, I can write this W is equal to, now see how to simplify this, minus mg y2. This minus minus will become plus mg y1. This minus minus will become plus, that is mg y1. Clear about this? Clear about this? Okay. W is equal to minus mg y2 plus mg y1. And see, I can also write this term as minus mg y1. Yes or no? Minus mg y1. So now see, that is one interesting result. W is equal to minus mg y2 minus mg y1. Yes or no? Yes or no? Okay. So this term mg and some height. So yes, these two terms, they represents the same dimension. Clear about this? Clear about this? And see one important thing. This W work depends on m, mass of block, always constant. G, gravitational constant. Yes. Y2 and Y1. Y1 is initial height of block and Y2 is final height of block. Okay, final height of block. Yes or no? And as in definition of work, it is displacement. So if you bring object from this point to this point on this path, or any path, displacement between these two positions will remain same. These two positions will remain same. So here from this equation we can say, okay, here work done depends on initial and final position, only. It does not depend on path joining two positions. Okay, see in this case, initial position, final position. If I am taking this path or if I am taking this path, in both cases work done will be same. If I am taking another path in this direction, work done will be same, because Initial position is fixed, final position is fixed. So here work done depends on initial and final position only. It does not depend on path joining two positions. Clear about this? Okay. Such forces, such field forces are called conservative forces. Conservative forces. Such field forces are called conservative forces, and field is called conservative, and field is called conservative field. Clear about this? Okay, any doubt? Now see here, W is equal to minus mgy2 plus mgy1. So yes, I can write like this. It is mgy1 minus mgy2. Yes or no? It is mgy1 minus mgy2. mgy2. So this term, left hand side it is work. Dimension of work, unit of work is joule. So right hand side must correspond to some energy. It must correspond to some energy, and it is nothing but potential energy. Okay, left hand side equation. Okay, it corresponds to some energy. Which type of energy? It is energy due to its position. Initially at position y1, finally at position y2. So understand what potential energy or capacity to do work by its position. So now, what is potential energy? See, here it is. Product of weight of object and its height from reference surface in gravitational field is called gravitational potential energy. Clear about this? Is called gravitational potential energy. If it is surface of earth, reference surface, one object of mass m is at height h, then what is potential energy of this object? Gravitational potential energy. Gravitational potential energy. U is equal to mgh. It is mgh, and it is called change in potential energy. See, here we have a statement that if force is acting on body, so due to change in position or configuration, potential energy also changes. So yes, W is equal to change in potential energy. And what is potential energy? Product of weight of object and its height from reference surface. Yes, in most of cases, we will consider reference surface as surface of Earth. Okay, so it is surface of Earth, reference surface at height h. We have one object of mass m. Then gravitational potential energy U is equal to mgh. So if height is increasing, potential energy also increases. Okay, if I drop a chalk on your head from this height, then it will not hurt. But if I drop some object from some more height, then obviously it will hurt. So why? What is reason? The object falling from height. Okay, they hurt. Okay, that we will see. Yes, it is about all potential energy. Again, reference surface block at height y1, block at height y2. Yes or no? To bring block from height y1 to y2, what is work? That work W is equal to, yes, it is minus mg y2 plus mg y1. We have obtained one equation. Yes or no? Yes. Now I am assuming as this block, it is in motion. We want to bring block from this position to this position. So yes, if we apply force, it is in motion. So I am assuming at this point that velocity of block, speed of block is v1. At this block, at this point, speed of block is v2. Yes or no? Yes or no? So yes, v1 speed at height y1, v2 speed at height y2. So let speed of object at height y1 is v1 and speed of object at height y2 is v2. So yes, what is work energy theorem? What is work energy theorem? What is work energy theorem? W is equal to delta K is equal to K2 minus K1 is equal to half m V2 square minus half m V1 square. Yes or no? Yes or no? It is half m V2 square minus half m V1 square. That is final kinetic energy minus initial kinetic energy. Final kinetic energy minus initial kinetic energy. Yes or no? Yes. It is work to bring block from this position to this position. It is also work done during this process. Yes or no? So yes, we can compare these two equations. We can compare these two equations. Compare equation 1 and 2. Compare equation number 1 and 2. So if we compare these equations, see what happens. It is minus mg y2 plus mg y1 is equal to equation 2 half m v2 square minus half m v1 square. Clear about this? Now take terms having one side and two another side. So yes, here it is mg y1. Mg y2 I will take this side and half m square I will take this side. So it is half m v1 square plus mg y1 is equal to half m v2 square plus mg y2. Clear about this? Clear about this? It is called kinetic energy at this point. So it is K1 kinetic energy. Mg y1 potential energy at this position U1 is equal to half m v2 square means kinetic energy K2 and then mg y2 means it is U. To see what is this equation? Addition of summation of kinetic energy and potential energy at this position is equal to summation of kinetic energy and potential energy at this point. Yes or no? So it means addition of kinetic and potential energy. Addition of kinetic and potential energy remains same. Addition of kinetic and potential energy remains same. Their addition. So yes, we can write their addition as something, and that something is E1 is equal to E2. Where see addition of or summation of kinetic energy and potential energy is called mechanical energy. Is called mechanical energy. Total energy is called total energy. Clear about this? And E1 is equal to E2. It means what? At this point total mechanical energy. At this point total mechanical energy. They are same. Means it is constant. So in conservative field, total mechanical energy remains constant. Total mechanical energy remains constant. Clear about this? Clear about this? And it is nothing but law of conservation of energy. Law of conservation of energy. It is law of conservation of energy. Clear about this? Okay, at this point energy is E1, at this point energy is E2, that is E1 is equal to E2. And what is it? What is mechanical energy? Kinetic energy plus potential energy. What is mechanical energy? Kinetic energy plus potential energy. Their addition is always constant. Now, you may ask, sir, how addition remains constant? Yes or no? Yes. If I have this job on surface of Earth, so height is 0, so potential energy is 0. In rest condition, so kinetic energy is also 0. Yes or no? Yes. If I am doing some work to bring this chalk in upward direction, or if I throw this chalk in upward direction, I throw means initial speed is maximum, so kinetic energy is maximum. Now as it is moving in upward direction, we know that its speed decreases. Speed decreases means kinetic energy decreases, but height increases. So yes, when we throw any object in upward direction, its kinetic energy decreases, but potential energy increases, and the amount by which kinetic energy decreases is equal to by amount potential energy increases. Clear about this? On maximum height, its velocity becomes 0, so kinetic energy is 0, but at maximum height is maximum, so potential energy is maximum. So potential energy is maximum, and after that it will again move in vertically downward direction. So if this chalk is moving in downward direction, height decreases means potential energy decreases. But we know that Galileo's law. Okay, if it is moving in downward direction, its speed increases, so kinetic energy increases. Clear about this? So yes, you have to remember this point. If kinetic energy increases, potential energy decreases, but their addition remains the same. And it is law of conservation of energy. Clear about this topic? Yes. In detail, what is law of conservation of energy? What are changes in kinetic and potential energy? We will see with the help of some examples. Okay? But yes, it is one important topic. What is potential energy? In future, in chapter number 8, we will study about gravitational potential energy again. In chapter number in 12, we will study about electrostatic potential energy. And in this chapter, we will study about elastic potential energy. So, concept of potential energy is important. Okay?